This is a brief and probably quick review of scientific notation. I'm assuming you have been introduced to the topic before, so I'm not going to spend a lot of time explaining the background of this. Here's a number written in scientific notation. It's nearly always in this same format, with a number between 1 and 10, in this case 7.9, and x that symbolizes multiplication, and a power of 10, in this case 10 to the 13th. Here's another number written in scientific notation. Again, a number between 1 and 10, the 2.31, and x, and a power of 10. The negative exponent on the 10 here tells us this is a small number between 0 and 1. The negative exponent has nothing to do with the sign of the number itself. Here's another number written this way, fairly large number this time. This would be the mass of the sun in kilograms, and it's got the same format again, a number between 1 and 10, and x for multiplication, and a power of 10. Here's a very small number. We can tell that because the exponent on the 10 is negative and a fairly large negative exponent. And again, the same format, a number between 1 and 10, multiplication symbol, and a power of 10. And here are a couple more. Every time the format is the same, a number between 1 and 10, an x for multiplication, and a power of 10. Take a look at the number 29,500. We can write this number as a product of 2.95 and 10,000. 2.95 is the number between 1 and 10, and 10,000 happens to be a power of 10. It happens to be 10 to the 4th. So I can replace that 10,000 there with 10 to the 4th, and I'll have a number in scientific notation. So there we have it. By the way, just for a quick review, here are some powers of 10. 1 million happens to be 10 to the 6th. 100,000 is 10 to the 5th. 10,000 is 10 to the 4th. 1,000 is 10 to the 3rd, and 100 is 10 to the 2nd. Here's another large number, one we could read as 6,380,000. You can write this as a product of 6.38 and 1 million. But 1 million, again, happens to be a power of 10. You can write that 1 million as 10 to the 6th. So you can replace the 1 million in the expression above there with 10 to the 6th. And you've written 6,380,000 as 6.38 times 10 to the 6th. Now, the last two things I did, I've talked you through converting these numbers to scientific notation, but that isn't really the way that it's done most of the time. Let's take a look at the way that we usually do this, and we'll redo that 29,500 using the more standard method. When you convert a number to scientific notation, you start by looking at where the decimal point is or is assumed to be or understood to be in standard notation. Then you look at where the decimal point will end up for scientific notation, and we'll figure out how many places we have to move the decimal point to write it that way. You can see you had to move that decimal point 4 places. The comma doesn't count, but there is a place between the 9 and the 5 there. Since we had to move it 4 places, that will end up being the exponent on the 10. This is a big number, so we'll have a positive exponent on the 10. It'll be 10 to the 4th. So 29,500 is 2.95 times 10 to the 4th. Let's do another one. This is the number of feet in a mile. Let's put that in scientific notation. There's where the decimal point is understood to be. That's where we'll want it for the scientific notation. How many places do we have to move it? You can see 3 times there. So this will have to be 5.28 times 10 to the third. Now let's look at some small numbers and see what happens in those cases. 0.3, you can also think of that as 3/10. 3/10 happens to be 3 times 1/10, and 1/10 happens to be a power of 10. In fact, it's 10 to the minus 1. So we can rewrite 0.3 as 3 times 10 to the minus 1. Now, we don't usually bother to write numbers like 0.3 in scientific notation, so let's look at a smaller number. Here's one that's much more likely to be written in scientific notation, 0.000653, which is 6.53 over 10,000. That took a little bit of work to get, but it can be written that way anyway. Now remember that 10,000, or 1 over 10,000, you can write it that way. The 1 over 10,000 is a power of 10. It's 10 to the minus 4th. So we can write that 0.000653 as 6.53 times 10 to the minus 4th. Now let's look at the easier and quicker method to convert a number, small number. We start off looking at where the decimal point is in standard notation, look at where we will want it to be for scientific notation. It will have to be moved 4 places. So we'll have an exponent of 4 on the 10, but because this number is less than 1, it's between 0 and 1, we'll want a negative exponent, so that 0.000341 we would write as 3.41 times 10 to the minus 4th. Let's do one more here. This one, let's see, what is that? 0.000006754. There's where the decimal point is in standard notation. That's where we'd want it in scientific notation. How many places do we have to move it? 1, 2, 3, 4, 5, 6 places. So we'll want a 10 to the minus 6 for the multiplier, and 6.754 times 10 to the minus 6. Okay, here's some extra practice. There are some large numbers. With that last one, you can probably see why we might want to write it in scientific notation. Actually, all 3 of those. And here are some small numbers. It might be a good idea to pause the playback right now and work these all out on your own. And I'm just going to show the answers, not go through the arrival at them or anything like that. Okay, let's have a look at what the answers are. All right, hopefully you got those right. If not, you might try those again, see if you can figure out why you missed it. A couple other things I want to show you. Metric prefixes show up on numbers. For instance, this number here, 5.2 mm, means 5.2 millimeters. It may be that you want to have that number in meters instead. And I'll show you how to convert that here. First of all, when you have a number written with that mm afterwards, the second M means meter, and the first M, the leftmost one, means milli. And in the metric system, that milli has a particular meaning. It means 10 to the minus 3. So you can replace that first M, the leftmost M, with 10 to the minus 3. Actually replace it with times 10 to the minus 3. And 5.2 millimeters is 5.2 times 10 to the minus 3 meters. Here's another number, 542 nm. This would actually be a wavelength of visible light. That would be in the green part of the spectrum. But we might want to have that written in meters instead. The nm means nanometer. The N stands for nano. In the metric system, nano has a particular meaning. It means 10 to the minus 9th. So we replace the N in the nm with times 10 to the minus 9th. And 542 nanometers is 542 times 10 to the minus 9th meters. That's it for now. If you have any questions about this, you can always rewatch the video or ask me questions in class or in office hours. The next step will be learning how to do this on a calculator and perform calculations with these.